Hey everyone, welcome to the channel. I am Rafael, and today we are diving into the fascinating world of software defined radios, or SDRs, a key technology for engineers and radio enthusiasts alike.
Software-defined radio for engineers.
Okay, let's start. And in this video, we study two about and chapter 1 and network and SDR, RF architecture for SDR, and chapter 2 signals and systems. Okay, the principles for data. In figure 1.2 we have a block diagram for AGF 1713 and LDOX, this block. We have in this LNA are low noise amplifier and receiver, synthesizer, transmitter, 2, digital baseband, ARM Cortex M0, memory RAM, interrupt controller, SPI slave, 8x configurable GPIOs. Okay, let's start. And next image, figure 1.3, an illustration describing some of the important components that constitute a modern digital communication system. Note that for SDR-based implementation, those components indicated as programmable can be realized in either programmable logic or software. In this begin, we have a data source. Next, source encoder. After channel encoder, symbol mode, DA converter, RF chain or radio frequency, and we have two antenna or antenna. Okay, all this is modulation. Okay, and in this point we have a discrete digital signal, and this point we have analog systems, analog signals. Okay, and in this we have data sync, source decoder, or whatever. We have an antenna, RF chain, radio frequency chain, analog digital converter, okay, symbol demode or demodulation for receiver, channel decoder, source decoder, okay, in this moment is more priority, and data sync. Perfect. And in this figure is very important for for study together, okay? Because we are all the systems complex systems. For example, this is an antenna, preselector, LNA or low noise amplifier, BPF or band pass filter, mixers, PLL, VCO for oscillator control voltage, BPF, EF amplifier or amplifications frequency intermediate, BPF, mixer, BPF, DSA or digital, and I'm sorry, and one moment please, is a digital step attenuator, okay, perfect, ADC driver, or converter analog to digital, ADC, digital filter, and PLL, VCO, clock gen, and this way, but left, okay? In this line, we have a receiver. In this line, we have a transmitter, okay? And this diagram block is very important because we present FPGA and filter program gate array for program and software other hardware, okay? In this block we have power management, sensors, and this is informations, audio or video or data in general, okay? Let's next figure. Okay, this figure is very important too. Figure 1.7, zero wave architecture. In this antenna, LNA in mixers, okay, and LPF or filter pass low 2. In this center we have PLL VCO oscillator controlled voltage. In this diagram block we have a 0 degrees, 90 degrees phase splitters, and in this line we have a signal and cosenoid, okay, and phased with carrier. In this signal we have a sinus and the phased 90 degrees of carrier, okay. In the end we have a converter analog digital into in these two in that two. eh, we have a channel in phase, okay, and we have a channel quadrature, and together we have a signal EK for informations and between phase, frequency, or amplitude too. In topic 1.5 processing architectures for SDR, we have integrative architecture using the Pluto SDR and this commercial product, okay, for analog devices. And we are basically front end analog, and we have to processing digital signals for this party the motherboard. Okay, daughterboard in left in and motherboard in right. This board. Okay, let's go. In chapter 2, signals and systems, and brief are introductions. SDR is an application-specific area of signal processing, and everyone involved in SDR development needs to only have a solid background in signals and systems, but also RF and analog baseband processing. This chapter covers the many aspects of linear time invariant (LTI) signals and systems, analog processing, and RF that form the fundamental basis for the later chapters. It is not expected the reader will go through each topic in detail, but if any of their short topics are new, the reader should refer to the more comprehensive books on these subjects. Okay, and for the next topics, we have conceptual explain for Fourier, Fourier transform or Gibbs phenomenon looking left, the time domain looking right, the Fourier domain. Okay, in this axis we have a magnitude for signal. In this axis we have a time. In this axis we have a frequency. This signal. Okay. Eh, and combined or matched this axis for this axis we have a signal for the time, magnitude for the x time, and signal analog. Perfect. But if we matched this axis of frequency for this axis and time, we have a discrete signals. Okay. More about Fourier transform and your conceptual mathematics. Okay. Next, we have a properties. We properties Fourier transform our definitions, inversion formula, linearity, symmetry, time shift, frequency shift, scaling, derivative, integration, time convolution, frequency convolutions. And this is last figure in this video, and we have a periodicity of the DFTs or transformed Fourier discrete Fourier transforms time domain signal. The time domain can be viewed as n samples in length show in the upper figure or as infinitely long periodic signals showing their lower figures. In this figure, the time domain viewed as n point. Okay, but and if I have less points for sample in signal, we are we we want the alliance for the bad notches for our engineers. Okay, alliance is not good. And okay, and in this case, we have to apply filter anti-aliasing for mitigation this is effect. Okay, good. And for this video, it's all informations, and thank you for your attention, and subscribe, comment, and like it if you're like this video. Perfect. And thank you for these attentions again. See you